Hello students, I am Hakim Abdullah, Physics faculty. Through this video, you are going to study the concept behind large length pendulum. Okay, large length pendulum means whose length is comparable with the radius of Earth. Okay, so here you can see what is infinite length pendulum. Infinite length pendulum is actually a theoretical concept, actually a theoretical physics concept, where a simple pendulum's length approaches infinity. A simple pendulum's length approaches infinity, whose length becomes infinity, meaning its suspension point is incredibly far away. Generally, for a standard pendulum, whose length is very small, comparable from or with the height from the surface of Earth, whose time period formula is T equal to 2 pi root L by G. What is L? L is length of pendulum. Okay, length of pendulum means distance between point of suspension and center of mass of the bob. Okay, which is proved in your 11th chapter, in your 11th standard chapter Oscillation, that you already proved, right? Okay, derived this formula T equal to 2 pi root L by G. Okay, and for infinite length pendulum, infinite pendulums SHM, whose time period is not equal to 2 pi root L by G, we can't use 2 pi root L by G, and whose length is infinity, right? So some students may think L is infinity, sir. When L is infinity, time period also should be infinity. It is also wrong. Then what will be the time period of infinite length pendulum? This pendulum is actually what? Theoretical concept. But for this theoretical concept, we can prove mathematically formula for time period, which was asked in various competitive exams, including JEE Main and Advanced, and may be asked for NEET also, because the concept is not scary. Okay, it's simple concept, just to watch the video carefully. Okay, let's go. What is the difference between normal or standard pendulum and large length pendulum? For short pendulums or standard pendulums, curvature of Earth is negligible, because point of suspension will be at a very small height from the surface of Earth. So from a small height, we see Earth is flat. Actually, Earth's surface is not flat, but we can say Earth's surface is flat, because from a multi-story building, 10th floor, 15th floor, 5th floor, while we are observing surface of Earth, we see, okay, surface of Earth is flat. Actually, it is not flat, right? Okay. For large length pendulums, curvature of Earth should be taken into account while we are moving to very high distance, to a very high, using an aeroplane or in a rocket. Then while distance from the Earth's surface increases, we can observe that Earth's surface becomes curved. Earth's surface becomes curved. So for large length pendulums, curvature of Earth should be taken into account. Then what happened? What will be the time period of pendulum? That we are going to calculate. Okay, large length pendulum. After discussing concept of large length pendulum, okay, large length pendulum means length can be compared with radius of Earth. Radius of Earth, that is large length pendulum. Okay, whose time period will be what? That we are going to derive. Okay, listen here. This is the center of Earth. Assume this sphere is Earth, right? So this point is center of Earth. Okay, and there is a large length pendulum which is situated, whose bob is situated just above Earth's surface, and so this will be the point of suspension, and this is the equilibrium position, or we can say it is mean position. What is MP? MP is actually what? Mean position or equilibrium position. Mean position or equilibrium position. And the pendulum is slightly displaced on either side with a small angular displacement theta. This angular displacement is theta, which is very small, okay, slightly displaced. So the pendulum gets a linear displacement of x from mean position, linear displacement of x from mean position, okay, it is the linear displacement, okay, x from mean position. So at this position, tension acting on the string of the pendulum is T, and this tension we can resolve into two components, okay, one vertical component, one with upward direction and one with a horizontal direction. If this angle is theta, we can say this angle is also same angle theta. So vertical component will be T cos theta and horizontal component will be T sin theta, okay. And what is the direction of weight acting on the bob of the pendulum? Weight mg normally we are taking directly downwards, and here we can't take like that because weight is always acting towards the center of the earth, right? Normally while we are taking weight, so weight will be directly downwards towards the center of earth, right? But here for large length pendulum and the pendulum is displaced, the bob is displaced a little bit, then weight mg is not directly downwards, it is directly towards the center of earth, inclined a little bit, okay. So this is the direction of weight mg, okay. Then this for weight mg we can draw two components, okay. One component directly downwards opposite to T cos theta. I am taking this angle as it is not theta, it is another angle alpha. So I am taking mg cos alpha opposite to T cos theta, okay. And one component along T sin theta, right? What is that component? Mg sin alpha. Do you agree? Yes, mg sin alpha, okay. So this is the length of pendulum L. And what about this? This one is actually approximately radius of earth r. Radius of earth r. Can you see it? This is radius of earth r and this is length. Okay. Very near to radius of earth because bob is just above the ground earth surface. That is why I am taking that distance r as r. Okay. Now here is a triangle, right? This triangle I can recreate in this sense also. I can recreate this triangle. So this angle will be what? This angle also will be alpha. This angle also will be alpha. Okay. Now take vertical equilibrium condition. What is vertical equilibrium condition? In vertical equilibrium condition, we can say T cos theta balances what? Mg cos alpha. T cos theta balances mg cos alpha. Okay, do you agree? And you know, very slightly displaced the pendulum. Pendulum is very slightly displaced. So theta will be very small. Theta will be very small. Theta is very small. When theta is very small, we can say alpha is also what? Very, very small. When theta is very small, alpha also should be very small. Alpha also should be very small. For very small angle, what is the value of cos? Cos theta and cos alpha, then approximately we can say 1. Cos theta and cos alpha approximately equal to 1. So from here we can conclude tension is approximately equal to mg. So we can conclude tension in the spring will be approximately equal to mg. That we got. Okay. Then this result we have to apply in the second case, okay, in the horizontal condition. And here for a material or for a body in SHM, there should be a force acting towards mean position, restoring force. Okay, and here forces acting in horizontal directions are what you can see here towards mean position. Forces acting are T sin theta and mg sin alpha. T sin theta and mg sin alpha, the two forces are the reason for going back the bob towards its mean position. Actually, the two forces are the reason for simple harmonic motion. So, restoring force towards mean position, F equal to mg sin alpha plus T sin theta. Do you agree? You want to look it back again? Okay, you can see T sin theta and mg sin alpha. T sin theta and mg sin alpha. Okay. So T sin theta and mg sin alpha. So restoring force we can write it as Kx. So Kx equal to mg is equal to what? T. Or we can say mg. What is sin alpha? Here, look, what is sin alpha? Here, what will be sin alpha? Sin alpha equal to, we can see, alpha opposite side is x and hypotenuse approximately radius. So sin alpha is x by r. Sin alpha is x by r. Okay, right? And what about sin theta? Can you say? What is sin theta? Sin theta is x by L, length of the pendulum. So we can give sin alpha and sin theta there. Sin alpha x by r, sin theta x by L. So substitute there. Sin alpha x by r and t into sin theta x by L. Sorry, one point higher I missed. What? T is mg, right? T is what? mg. mg into what is sin theta? It is x by L. So Kx equal to, we can take mgx outside. So inside bracket there is 1 by r plus 1 by L. So we can cancel out. What we can cancel out? X we can cancel. So we will get k equal to mg into, so we can write L first, right? So 1 by L plus 1 by r. This is the force constant or spring factor of large length pendulum. What is this? Force constant, or you can say it is what? Spring factor of large length pendulum. Spring factor or force constant of large length pendulum. Okay. You understood what I did? I just compared the forces acting horizontally towards mean position with the restoring force Kx. Then I got K. Okay. Then we got force constant or K as what? Mg into 1 by L plus 1 by R. Now, what is the general equation for time period of SHM? Time period of SHM general equation, T equal to 2 pi root m by k. What is m? Inertia factor. What is k? Spring factor. Mass by k. Spring constant or force constant. So you substitute k there. So 2 pi root m by, what is k? mg into 1 by L plus 1 by R. Yes. Here you can cancel what? M cancel. So what is the time period? T equal to 2 pi root 1 by G into 1 by L plus 1 by R. What is this? This is the formula of time period of SHM of large length pendulum. Time period of SHM of large length pendulum. Time period of SHM of large length pendulum. Okay. In some institutes, some teachers will say you just by heard this formula as shortcut. What? T equal to 2 pi root 1 by G into 1 by L plus 1 by R. Okay. It's also enough, because we actually for entrance exams, just like NEET and JEE, we do not require derivation. We require only the equation, final equation. So using this equation we can find time period of infinite length pendulum, large length pendulum, okay, and standard pendulum also. So this equation you can study as a shortcut, okay, and to find time period of large length pendulum, okay. But for JEE Advanced, we have to develop the concept from beginning, and we have to develop the final result or derive the final result also. Okay. Now, can we use this formula, which formula that we derived to find time period of small length or standard pendulum? Yeah, sure. For small length or standard pendulum, okay, length will be very less than radius of earth, right? Length will be very less than radius of earth. So 1 by L will be very greater than 1 by R. 1 by L will be very greater than 1 by R. So we can say 1 by L plus 1 by R, approximately we can make it as 1 by L only. Okay, 1 by L plus 1 by R, approximately we can say 1 by L. So time period equation, T equal to 2 pi root 1 by G into 1 by L plus 1 by R. So we are making 1 by R as 0, 1 by L plus 1 by R as 1 by L. So what will be the equation? T equal to 2 pi root 1 by 2 pi root 1 by G into 1 by L. So L will go to the numerator. So we will get T equal to 2 pi root L by G. So this formula we can derive. From the large length pendulum time period formula, T equal to 2 pi root L by G. This is the standard pendulum's time period formula that we already know. Okay, that we proved in 11th standard. Okay, right, in the chapter oscillation. Okay, but not this method, right? Okay. Now we can do 3 questions based on the concept that we already discussed. Question number 1. Time period of simple harmonic motion of infinite length is? Time period of simple harmonic motion of infinite length pendulum. Okay, how to find? Length is infinity, right? Length is not defined means 1 by L is 0. Okay, then what will be the equation? T equal to our equation. What the equation? The equation that we proved, 1 by G into 1 by L plus 1 by R. Here 1 by L becomes 0, right? So what will be the equation? T equal to 2 pi root 1 by G into 1 by R. That means T equal to 2 pi root R by G. This is the time period of infinite length pendulum. T equal to 2 pi root R by G, not 2 pi root L by G. Okay, and not infinity. Okay, so here we can T infinity, we can say T infinity, 2 pi root R by G, and we can find its value also. How to find the value? Okay, what is R? Radius of Earth. Radius of Earth is actually 6,400 kilometer. So this we can write 6,400 kilo 10 raised to 3 meter, right? Okay, and what is G? G actual value on Earth's surface is 9.8 meter per second square. So we can approximately say it as 10 meter per second square. So T equal to 2 pi root R by G. What is R? 6400 into 10 raised to 3. It is 1000, right? Divided by 10. So 10 will be cancelled. 10 will be cancelled. So we can say on numerator it is 2 pi root inside root 6400. 64 root is 8. Then 100. Okay, 100 square 100. So no need of root here. No need of square root here. Okay, 2 pi into 8 into 100. Okay, 2 pi 800 into 2 pi. So T approximately we can say 1600 pi second. Okay, so giving value of pi 3.14, we will get value approximately, or while we are giving G value 9.8 correctly, we will get time period 5075 seconds. This is the actual value while we are giving 9.8 meter per second square for G. Okay, T equal to 5075 seconds. It is equal to 84.3 minutes and it is equal to 1.4 hour. 1.4 hour. So, what is the time period of infinite length pendulum? 5075 seconds, 5000 something seconds, or 84.3 minutes, or 1.4 hour. Okay, so what will be the result or answer? Answer is option B, 84.3 minutes. This is the time period of infinite length pendulum, whose time period is not infinity, right? Okay, it is 84.3, or you can see the equation also. T equal to, in some exams they asked the result 2 pi root r by g. Okay, now we can go to next question. Question number 2. Time period of simple harmonic motion of a pendulum having length equal to radius of earth, whose length is equal to radius of earth. What will be the time period? That's the question. So time period equation, 2 pi root 1 by g into 1 by L plus 1 by r. Here we can't use 2 pi root L by g, and here we can't use 2 pi root r by g. Okay, so here L equal to what? R. So what will we get? 2 pi root 1 by g into 1 by r plus 1 by r. It is actually what? 1 by r plus 1 by r is 2 by r. So we will get T equal to 2 pi root r by 2g. Hey, 2 pi root r by g is what? Time period of infinite length pendulum, right? So time period of infinite length pendulum divided by root 2. Okay, because there is extra root 2 inside on the denominator. So T infinity, what is T infinity? T infinity is actually what? It is near to 1.4 hour, right? Divided by root 2 value is 1.414, approximately 1.4 is enough. Okay, so it is what? 1 hour. 1 hour is how much? 60 minutes. That is equal to 3600 seconds. So which option is right? Option C, 60 minutes. Okay, just to calculate, nothing to do. Okay, just to calculate, apply the equation that we derived. Okay, now go to next question, the last question. Okay, question number 3. Time period of simple harmonic motion of pendulum having length 3200 kilometer. Hello, what is 3200 kilometer? It is actually half of 6400 kilometer. That is equal to r by 2. So length is actually what? R by 2. So our equation is T equal to 2 pi root 1 by g into 1 by r plus 1 by L, or you can say 1 by L plus 1 by r. So give r by 2 instead of L. So what you will get? 2 pi root 1 by g into, what is r by 2? 1 by L is r by 2. So 1 by L is 2 by r. So 2 by r plus 1 by r. What is 2 by r plus 1 by r? 2 by r plus 1 by r is 3 by r. 2 by r plus 1 by r is 3 by r. So T equal to 2 pi root 1 by g into 3 by r. So what will we get? T equal to 2 pi root r by 3g. 2 pi root r by 3g. How to calculate? T equal to T infinity by root 3. Why T infinity? 2 pi root r by g is what? 2 pi root r by g is what? T infinity. So T infinity, it is 1.4 hour, right? What is root 3? 1.732. So 1.4 by 1.7? Less than 1, right? Less than 1 hour. Less than 1 hour. Less than 1 hour. Look, the options. Option A, infinity is wrong. Option B, 84.3 minutes is wrong. Option C, 60 minutes is wrong. So which option is right? Less than 1 hour, 48.8 minutes. Or you can calculate it also. So the concept is clear. You studied the equation well. Okay. And we did 3 questions based on that equation. Okay. Hope for the best. Stay tuned.